Okay, the notation we see here, bracket 2 comma 3 semicolon 4 comma negative 5 bracket, means this matrix. The key to interpreting this is rows are separated by semicolons. So this is a row, 2, 3, and this is a row, 4, negative 5. So this is the first row of the matrix 2, 3. Now, when we write the matrix out, we don't include the comma, we just include the numbers 2 and 3. And similarly, when we write the second row, we write the 4 and the negative 5. So we have a matrix with 2 rows, 2, 3, 4, negative 5, and 2 columns, 2, 4, 3, negative 5. In class, people had no trouble interpreting this as soon as I explained the interpretation of the semicolon, the interpretation of the comma. Okay, now we want to talk about the determinant of this matrix. The determinant of the matrix is what we get when we multiply the numbers on what we call the main diagonal, the diagonal that runs from left to right and top to bottom, the product of the first number in the first row and first column, and the number in the second row, second column. That would be 2 times negative 5. And then we multiply the numbers on the other diagonal, the first row, second column number by the second row, first column number, and we subtract that from the product of the first diagonal. So it's this diagonal minus this diagonal. And the arithmetic, even I won't screw this up that often, 2 times negative 5 is negative 10, 3 times 4 is 12, we subtract that, we get negative 22. Now there are a couple of other determinants that you're asked to do. Okay, well, let's look at this one. We got 32 times negative 5, there we have it, minus 3 times 18. And I emphasize that the minus is just because this is the second diagonal, that there's no negative on the 3 or the 18, the minus is here. So I grouped the 3 and the 18 just to emphasize that. Anyhow, that's negative 160 here, negative 54 here gives us negative 214. Okay, now the determinant here, 218, 32, 4. Okay, 2 times 18, just 2 times 18, minus the 32 times 4. Emphasize the structure by putting a set of parentheses. The parentheses are not really essential here, but if this number happened to be negative, it would be really easy to just write the negative here and think that you had that negative sign. You have a negative because this is the second diagonal. And then if 32 happened to be negative, you'd have a negative 32 in here and be less likely to mess up the signs if you did use the parentheses. Okay, well, one way or the other, this is 2 times 18 minus 32 times 4, that's 36 minus 128, and gives you negative 92. Now, this matrix here is related to this system of simultaneous equations down here, and we've seen that sort of relationship that the numbers, the coefficients in this matrix, 2, 3, 4, negative 5, are the same as the numbers in this matrix. Now there are a couple of other things that we see. If we look at this matrix, we see our 3218 in the first column. And the second column is the same as that of the coefficient matrix, the 3, negative 5. So we kind of take our 3218, put it here, our 3, negative 5, and put it here. You might wonder why, but I'm going to explain that in a minute. I just want to show you the pattern, okay? And here we did the same thing, except we replaced the second column of the coefficient matrix by the 3218. First column is the same as that of the coefficient matrix. It turns out that we can use these three determinants to easily and quickly solve this system without having to go through the elimination or row reduction or other processes, substitution, etc. Graphing, So we're going to say that, well, this first matrix, this matrix here, where we replaced the first column by 3218, is going to be used to determine the value of x. And the way we can think of that is when we're trying to calculate x, we're going to have a numerator matrix and a denominator matrix. Okay, the denominator matrix is our coefficient matrix. That's always going to be the case whether we're solving for x or y. See, we have a solution for x and y, and we have the same determinant in the denominator of both. In the numerator, we take that coefficient matrix and replace the x column, the column that has the x coefficients, by the 3218. And when we do a solution for y, we replace the y coefficients with the 3218. And there's our pattern for calculating our x and y values. Now, we've already done the determinants, but in a normal application, you would have your two equations. You'd write down your coefficient matrix, and that would be in the denominator with the determinant of the coefficient matrix. And then you would write down your numerator matrices and take the determinants of those. And again, your numerator matrix, when you solve for x, you replace the x coefficients with the numbers to the right of the equal sign. When you solve for y, you replace the y coefficients with the numbers to the right of the equal sign. Then you just calculate the determinants, and that's just a very straightforward arithmetic operation that I think I screwed up in class a couple of times, at least in one of the matrices. But the determinant of this matrix we've already seen to be negative 214. The determinant of this matrix we've seen to be negative 22, so our x is negative 214 over negative 22, and we can reduce that to 107 over 11. Okay, the y is going to be the determinant of this matrix, which we've seen to be negative 92, divided by the determinant of the coefficient matrix, which is negative 22, and negative 92 over negative 22 reduces to 46 over 11. So this tells us that our solution should be x equals 107 over 11 and y 46 over 11. Let's check that out and see if it actually works. Okay, so we check it. We substitute 107 over 11 for the x's here and here. We substitute 46 over 11 for the y's here and here. We do the arithmetic. 2 times 107 is 214. 3 times 46 is 138. 214 and 138 is 352. And 352 divided by 11 is 32. So this first equation checks out. We're pretty optimistic at this point. Well, we do the same here. 4 times 107 is 428. 5 times 46 is 230. 428 minus 230 is 198. 198 over 11 is 18. So yes, it does check out, and this system, this pattern is seen to solve the system of equations.